Hi, welcome back to my YouTube channel. In this video, we're going to discuss about Dockerizing the simple Java program. We will create a simple Java program, maybe hello world, and we're going to Dockerize that Java program, and we will create the Docker image, and we're going to run that image inside the Docker container. Let's begin. If you're watching this video, I believe that you already know about Docker, what is Docker and what is the purpose of using Docker. In case if you are very new to Docker, if you never heard about Docker before, then I suggest you to skip this video, go ahead and read few lines about Docker and then come back to this video and continue watching it. In this video, I will only show you how you can Dockerize the simple Java program. We will learn few Docker commands, the basic commands that you will use every day in your development. Let's begin. In order to use the Docker, first you need to install the Docker on your system. I have already downloaded and installed on my system. In case if you want to install it, you just need to go to the website, which is docker.com, which is the official website, and click on this get started, and you need to download this Docker desktop. It is available for all the operating system, Mac, Windows and Linux. Depending upon your operating system, download the Docker desktop and install it on your own. The installation is pretty straightforward. Once you installed it, you can verify it by running a command. Open the command prompt and you need to execute the command docker -v. This will display the Docker version which you have installed on your system. You might have installed the older version, that's completely fine. As long as if you see the Docker version, then you are good to go. Once you have installed the Docker on your system, you need to start it. You just need to start the Docker, and you can see the Docker is about to starting. This will take a couple of seconds to start the Docker. Once the Docker is started, you will see the dialog box, the Docker dashboard. You can see this is the Docker dashboard, but we are not going to use it. Let's close this. But if you see, the Docker desktop is running on your system. Now you can run the Docker commands. Okay, now let's open a Visual Studio Code. I have created a folder on the desktop, Docker tutorials. Inside this, let's create a Java file. I'm going to call this main.java. Inside this, let's write a simple hello world Java program. Public class main, public static void main, and let's pass the arguments, the string arguments, and inside this let's print a message to the console using println hello world. So let's save this. So in order to run this Java program, all we need to do is we need to first compile this and then we need to run the Java file. So let's do that as well. javac main.java. This will create the .class file. You can see now in order to run this Java main, and you can see hello world. Okay, so now we have created this Java file. Now we need to Dockerize this Java program. So let's do that. I'm going to delete this .class file, delete this. In order to Dockerize this, we need to create a Docker file. So inside the root of this project, we're going to create a file. The file name is Docker file. This file name does not have any extension, but it should start with the capital D. So inside this Docker file, we are going to provide instructions to the Docker that how you can run this Java program. So it starts with from. So this from instruction takes one parameter. We need to specify the base image. We have created this Java program using the Java code, and in order to run this Java program, we need JDK. So we need to tell Docker use a base image, which is JDK, to run this Java file or the Java program. So the base image name is open JDK : you need to specify the JDK version, which is 8. I'm going to use 8. If you want to use the higher version, you can specify the version number as well. I'm going to stick to Java 8. So this from instruction, we are telling Docker to use one of the base image, which is OpenJDK, to run this Java program. That is what the from command is, or the instruction is. Next, we need to set the working directory. Working directory, we need to specify the base directory. I'm going to provide the base directory name as /app. You can give any name you want. I'm going to keep it simple, /app. So now this is our base directory. Next, we need to use the copy instruction. We need to tell copy all the files to this base directory. So this copy instruction takes two parameters. The first parameter is the source path, and the second parameter is the destination path. So we need to copy all the files from the current directory. So we need to specify the dot. So this will copy all the files from the current directory, and we're going to add it to the base directory, which is /app/. Okay, we're going to add it to the base directory. Next, once we copied all the files, we need to compile the Java file. For that, we are going to use the run command, run instruction. So to this run instruction, we will provide the instruction which is javac in order to compile this javac main.java. Using this run instruction, we are compiling the file which is main.java. Once it is done, next we need to run the Java file. For that, we are going to use the entry point, and this will take array, and we need to specify the Java command to run the Java file, which is Java as a first parameter, and the second parameter we need to pass the class name, which is main. Let's save this. That's it. So now we have created this Docker file. We start with the from instruction. We are telling Docker to use the base image, which is OpenJDK, in order to run this Java file. So every software company, they have created their product as a Docker image, and they have pushed into the Docker Hub. Docker Hub is simply like a GitHub repository. So you will get all the softwares as a Docker images. So if you want to use any one of the product, you just need to pull it from the Docker Hub and you need to use it. That is what we're exactly doing here. We are pulling the Docker image for the OpenJDK from the Docker Hub, and we are using it. That is what the from instruction will do. So if you want to see where it is available, you can go to the browser and search for Docker Hub. You need to create a account inside this Docker Hub in order to use this. If you can click on this explore, you will see all the images that are available inside this Docker Hub. You can search for OpenJDK, and you can see we have the OpenJDK, and if you go inside this tags, we have so many versions of it. And if you want to use any one of this, you just need to copy this Docker pull and you can use it on your own. So, but inside this Docker file, we are using the OpenJDK as a base image, because in order to run this Java file, we need the JDK. So for that, we are using this as a base image, OpenJDK 8. And we are setting the working directory. We are setting the base directory, which is /app. You can give any name you want to this directory. And we are copying all the files from the current directory to the base directory, which is /app. And we need to compile the Java file. For that, we are using the run instruction, and we are providing the command. And at last, we are setting the entry point to our application using the array. Inside the array, we will pass the instruction with a comma separated, Java and main. That's it. So now our Docker file is ready. We need to build this. We need to build the Docker image. So for that, we are going to use one of the Docker command, which is docker build. The docker build is used to build the Docker image. This will take a few parameters. The first parameter is -t, which is the tag name. We need to provide the tag name, docker build -t, and you need to provide the tag name. I'm going to call this scbhushan05 /docker -hello world. and you need to specify the tag if you want. If you don't specify the tag name, it will by default it will take it as a latest. If you want to specify the tag name v1.0, that you need to specify. I'm not going to specify the version name tag name as of now. And last, you need to specify where it has to build. I'm going to build it inside the current directory. You need to specify the path as well, which is dot. This is going to build the image inside the current directory. And once you have done this, just click on this enter. This is going to start building the Docker image. So this will take a few minutes to build the Docker image depending upon your internet speed. In my case, it ran pretty quickly because previously I have used this image OpenJDK to run some other Java projects. That is why it was there in the cache. It has used it from the cache as well. That's why in my case it ran pretty quickly. But in your case, it may take a few minutes depending upon your internet speed. Once it is executed this command, once it is downloaded all these images, once it is done, you need to check the Docker images, the created Docker images by running the command Docker images. Hit enter. You can see we have the list of images which are present in my system. If you're running this for the very first time, then you will see only one image, which is just now you have created. I have a few other images as well. So right now we have this image scbhushan05/docker minus hello world, and you can see the tag name, which is latest, and the image ID, created, and size. Don't worry about this created time because I have used this OpenJDK a few hours back. That is why it is showing 9 hours ago. Okay, so now we have created this image. Now we need to run this image on a container. We need to start the Docker container. In order to start the container, we need to use the Docker run command. Docker run, you need to specify the image name, or you can specify the image ID. I'm going to specify the image name scbhushan05/docker minus hello world, docker minus hello world, and hit enter. You can see the message hello world. So when we run this Docker container, the Docker container has executed this file and it is stopped, because inside this, in order to run this Java file, we are not starting any server. If would have started any server, then the container should be keep on running. But now the container is started and it stopped as soon as it is executed this file. So if you want to check, you can check the command, which is docker ps. This command will display all the running containers. If you can execute this, you can see there are no containers are running. But if you see docker ps -a, this is going to display all the stopped containers as well. Hit enter. You can see the container, which is scbhushan05/docker hello world. This has been created 43 seconds ago and it has been executed 43 seconds ago. So the container is started. As soon as it executes the file, it has been stopped. So the docker ps -a, it will display all the containers, the running containers, as well as the stopped containers as well. And the docker ps, it will only display the running containers. Okay, so now we have created the Docker image and we have learned how we can start the container to run the image. Now you can give this image to any one of your friends. They can, if they have installed the Docker in their system, they can use this image to start the container. They don't have to install JDK in order to run this. That is the advantage of using the Docker. So they can just, if they have installed Docker, they just run the image using the container and application will be start running. That is the advantage of using the Docker. So now we have seen how to run the Docker, how to build the image, and how to run the Docker container. So in case if you want to remove the container, you just need to specify docker rm, which is for short for remove, and you need to specify the container ID to remove from the container. You just need to specify the container ID, which is 610. You don't have to specify the complete container ID. The first 3 characters is enough. Hit enter. You can see it has been removed from the container. Now if you see docker ps -a, there are no containers. Even the stopped containers is not available. But our image is still present. Docker images. You can see we have this image. If you want to remove the image from the Docker and execute the command docker image rm, which is for short for remove, and you need to specify the image id or the image name. I'm going to specify the image id 785, hit enter. You can see untagged and it has been deleted. You can verify that docker images. Now we do not have that image that we have created earlier. Okay, that's it for this video. In this video, we have learned how to dockerize the Java program, and we have run the image inside the Docker container, and also we have looked at some of the basic Docker commands. That's it for this video. In the next video, we're going to create a Spring Boot application, and we will learn how to dockerize the Spring Boot application. That's it for this video. I will see you in the next video. Hi, welcome back to my YouTube channel. In this video, we will discuss about dockerizing the Spring Boot application. If you remember, in the previous video, we have discussed about dockerizing the simple Java program, and this is the continuation of the same video. In this video, we will learn how to create a Spring Boot application and how to create a Docker image for the Spring Boot application, and we will run it on the Docker container. Let's begin. In case if you missed the previous video, the link will be given in the description section of this video. Go ahead and watch that. Just to save some time, I have already created this Spring Boot application with the name Docker tutorial. If you expand this inside the pom.xml, we have added the dependencies, the web dependency, the starter data.jpa dependency, Lombok, and H2 in-memory database, and the Spring Boot starter test dependency. And we have given the jar file name, which is Docker tutorial. Once we build the Spring Boot application, it is going to create the jar file with the name Docker tutorial. And we have used the Java version 1.8. Inside the source main Java, we have the controller model repository, and inside the resources, we have the data.sql file. It is going to create the employee table, and it is going to insert the two employee records, Bhushan and Bharat. And inside the application.properties, we are going to configure the data source for in-memory database. The database name is testdb, username, password, and we are going to enable the H2 console, and we will use the ddl -auto. We are going to set this to update. Pretty normal Spring Boot application. If you are experienced with developing the REST APIs with Spring Boot, then you can easily understand this. In case if you are very new to Spring Boot and if you don't know how to create a REST APIs in Spring Boot, then I highly recommend you to check out my course on creating a RESTful APIs with Spring Boot. You will understand everything. Alright, inside the controller, we have the employee controller. It is going to expose two REST endpoints, /employees for get mapping, /employees for post mapping. One is to save the employee details, one is to retrieve the employees from the in-memory database. Okay, so now we have the Spring Boot application. Let's go ahead and build this. So inside the Maven, first we're going to build the Maven project. Click on this install and click on this button. It is going to build the Spring Boot application. It is going to generate the jar file inside the target folder. You can see that build is success. Now inside the target folder, we have the jar file, which is docker tutorial.jar. Now in order to run this Spring Boot application, we can use the Java command. Let's open the terminal and let me clear this, and let's go to the target folder, cd target, and inside this we have a jar file. So in order to run that, we're going to use java -jar, and we will provide the jar file name, which is docker tutorial.jar. Hit enter. This is going to start the Tomcat server on port 8080, which is the default port. You can see the Tomcat started on the port 8080. Head over to the Postman and let's try a REST endpoint, localhost :8080/API/v1/employees. Click send. We do get the two employee records, Bharat and Bhushan. Okay, so now let's go ahead and dockerize the Spring Boot application. Let me stop the server. Let me clear this. Let me come out of this. Okay, so now let me minimize this. In order to dockerize this, first we need to create a Docker file. So at the root of the project, go ahead and create a file which is docker file. This file name does not have any extension, and inside this we will write the instruction. We will start with the base image. We will provide the base image, which is OpenJDK. We will use OpenJDK 8. Next, we need to use the copy instruction. Like I said, this copy instruction takes the source and destination. We need to copy all the files, not all the files. We need to just copy the jar file which is present inside this target folder, and we're going to copy it to the image with the same name, docker tutorial.jar. So let's do that. Target/docker tutorial.jar. We're going to copy this jar file and we're going to copy it to the image with the same name, docker tutorial.jar, the source and the destination. Next, we need to provide the entry point. This will take the array. We need to provide the Java command to run the jar file with a comma separated. Java -jar /docker tutorial.jar. That's it. So now our Docker file is ready. All we need to do is we need to build this. So we will start with the from. We will use the base image and we are going to copy the jar file to the destination, which is docker tutorial.jar, which is the destination path with the same image name. And we will provide the entry point, which is Java -jar /docker tutorial.jar. Let's save this. Now let's open the terminal. Let me open this inside the terminal. Docker. We need to build this. But I have to navigate to the folder, this docker tutorial. Instead of this, I'm going to run it inside the IntelliJ IDEA terminal itself. That is better. So Docker, we need to use the build command, docker build -t. We need to provide the repository name, Bhushan 1992 /docker spring boot. You can also provide the tag, which is v1.0, but I'm going to keep it simple. It is going to add the by default tag, which is latest. And we need to provide the location where it has to build. We're going to build it inside the current directory. So let's add dot and hit enter. This is going to start building the Docker image depending upon your internet speed. Okay, once it is built successful, Docker images, you can see the image, which is Bhushan 1992 /docker -spring boot, the latest, which is the tag, image ID, and the created 6 seconds ago, and 560 MB. Okay, now we have created the Docker image. All we need to do is we need to start this image inside the container. We need to start the Docker container. So for that, we are going to use Docker and we're going to use the run command, docker run, and we need to specify the port, on which port our application has to run, -p. We need to specify two ports, the host port and the container port. So the host port, which is 9090 : the container port 8080. By default, our Spring Boot application will be run on port 8080 inside the container. But we cannot access our application inside the container. So we need to map the container port to the host port so that we can access our application outside of the container. That is what the first parameter, which is the host port. We are going to access our application inside the port 9090. We are just mapping the container port to the host port. The first port is the one which we are going to access outside of the container. Just remember that. And we're going to provide the container image ID, which is 3F7. You don't have to specify the complete image ID, just the letters is enough. And the moment we click on this enter, it is going to start the container, and it is running on the port 8080, as you can see. And now if you go to the Postman, and in this port localhost 8080, if you try to access it, we will get the error because it is running inside the container, but we have mapped this 8080 to the another port, which is 9090, which is we can access our application. So let's change this to 9090. Click send. You can see we get the two records. So let me copy one of this and let's try another endpoint, or we can change this to post body, choose jar, and let's make it JSON and paste it. Let me remove this ID and let's add Shankar at example.com. Click send. You can see the post mapping is also working. And if you look at this, so inside this, actually we start the container and it is started the server, so that is why we are not able to access any of the commands now. We cannot execute any of the commands. We need to open a new terminal in order to do that. There is also one more way I will show you. So let me stop this. And now first of all, we can see the running containers. Docker ps, you can see there are no containers running because we have exited. We have exit from the container, but we can see the stopped containers. Docker ps -a, this is going to display the stopped containers as well. As you can see, we have stopped this container. And if you want to start this again, we can use the docker start, and we need to specify the image or the container ID, which is 31D. It is going to start it again. And if you look at the docker ps, you can see now it is running, which is 2 minutes ago, up by 5 seconds ago. This will take a couple of seconds to start. If you want to check the logs now, what you can do is docker logs. You need to specify the container ID, which is 31D, and you can see we get the logs. Okay, if you want to keep on seeing the logs, then you just need to add -f option. So logs -f, you can see it is it will be inside the, it will be keep on following the your logs. Okay, so you can just watch the logs. It will be in interactive mode. Okay, if you want to exit it, you can just Control C, it will come out of this. You can go ahead and try this again. Container is started. So let me change this to get. Click on this send. You can see we get the 2 records because we have restarted it again. That is why we get the 2 records. This was inserted earlier, and after that we have stopped the container again and we have restarted. So we get the fresh new database which is having the 2 records. Okay, so let me do this. Let me click on this post, click on this send. We do get the new records. Now let's switch back to get. Click on this send. We do get the 3 records, which is Bhushan, Bharat and Shankar. Okay, so in case if you want to stop it, like I said, you just need to press Control C. It will be exited. You can see the docker ps -a. You can see the stopped container. If you want to remove this container, docker remove rm and 31d, which is the container ID, hit enter. This will be okay. This has been not deleted because okay, they cannot remove a running container because stop the container before attempting removal of force mode. Okay, this is because our container is docker ps. You can see the container is still running, and first you need to stop this. Docker stop, you need to provide the container ID, which is 31d. Now it has been stopped. Now you can remove this. Docker remove 31d. And now if you see docker ps -a, we do not have any containers, but docker images, we have still image. So if you want to remove the image, docker image, you need to provide rm, which is short for remove, and you need to specify the image ID, which is 3f7. Hit enter. This will be untagged and deleted. Now if you see, we do not have the image. Alright, this is all about Dockerizing the Spring Boot application. I hope you enjoyed this video. If you liked it, go ahead and click the thumbs up button and also subscribe to the channel for future videos. I will see you in the next video. Hi, welcome back to my YouTube channel. In this video, we will discuss how to Dockerize the Spring Boot application with the MySQL database. In the previous video, we discussed about Dockerizing the Spring Boot application with the in-memory database. In case if you missed that video, the link will be given in the description section of this video. Go ahead and watch that video. There are 2 different ways to Dockerize the Spring Boot application with MySQL database. The first approach is by creating a Docker network, and the second approach is by using the Docker Compose. In this video, we will discuss about using the Docker network. Let's begin. I have created a text file and I have written a series of steps that how we can Dockerize this Spring Boot application with MySQL database, and we are going to follow these steps one by one. We are going to Dockerize one of the REST API, which is Expense Tracker API. This is a production ready REST API. In case if you don't know how to create a production ready REST API with Spring Boot, JPA and Hibernate, I highly recommend you to check out my Udemy course, where I will teach you everything you need to know about Spring Boot, JPA, Hibernate, and deploy the application to the AWS and Heroku. Go ahead and check that course. The link will be given in the description section of this video. So the first step is we need to pull the MySQL image from the Docker Hub. Let's open the command prompt or open the terminal. In case if you are on Mac, we're going to use docker pull command. Docker pull image name MySQL : the version 5.7. Hit enter. This is going to pull the MySQL image from the Docker Hub depending upon the internet speed. For some reason we are getting this exception. In case if you are also facing this exception, which is no matching manifest for Linux /ARM64/v8, then you need to append the platform option. Let's use the other option, other command, which is docker pull -- platform Linux /x86_64. Let's use this. We just need to add the platform option and hit enter. This is going to pull the image from the Docker Hub. This will take a couple of minutes depending upon your internet speed. As you can see, it starts pulling the image. We have pulled the image from the Docker Hub. We can verify that Docker images. You can see we have this MySQL image with the tag 5.7. Let me clear this. The second step is we need to create a Docker network to communicate the Spring Boot application and the MySQL database. Basically, we are going to create a network to communicate the Spring Boot application and the MySQL together. It is a bridge between the two services. We're going to use Docker network create. We're going to use the create option and we will provide the name. We are going to use the network, which is Spring Boot -MySQL -net. You can give any name you want. Hit enter. This is going to create a network. We can verify that Docker network ls, and you can see the network, which is Spring Boot -MySQL -net, and you can see the driver, which is a bridge. Like I said, it is a bridge between the MySQL database as well as the Spring Boot application. And the third step is we need to run the MySQL container inside the network. We're going to use docker run command and we're going to provide a name to the container using the -- name option. We're going to call this MySQL DB and we're going to run it on the network which we have created using the -- network option, and we will provide the network name, which is Spring Boot -MySQL -net, and we are going to use the environment variables. We have a couple of environment variables. MySQL -_root_password. We're going to set the root password, which is 1234. You can give any password you want, and we're going to use one more environment variable, MySQL_database. We're going to provide the database name expense tracker, and we're going to use the another environment variable, which is user, and I'm going to set this to SA, and password, the user password, I'm going to set this to 1234. Basically, just to keep it consistency, we're going to use the same password with the root password as well as the user password, and we're going to run it in the detach mode, and we will provide the image name, which is MySQL: 5.7. So let's copy this and paste it and hit enter, and we will get this warning. You can just ignore this, but you can see the container ID. The container is started. We can verify that. Docker ps, hit enter. You can see the MySQL is started on the container. Now we can see whether the database is created or not. Let's run this container in an interactive mode. We will use docker access and -it, which is interactive mode, and we will need to provide the container ID 454, and we're going to use the bash command. Now we are inside the container, and we will use MySQL -u, which is the username. We set this to SA, and -p, we set this to 1 2 3 4. Hit enter. Now we are inside this MySQL database. We can check the databases. You can see we have the expense tracker database. Let's see, select the database, expense tracker, and now we are inside the expense tracker database, but there are no tables inside this database because we haven't started our Spring Boot application inside the container. Let's do that. That is what the next step is. The fifth step is to update the application.properties file. We need to add these properties. Basically, we are going to change the URL. Instead of the localhost, we are going to use the container name. If you remember, we have given the container name for running this database, MySQL database, and we need to use this container name instead of the localhost, and we need to provide the username and the password. So let's copy this, and inside the IntelliJ IDEA, let's open the application.properties file. Let me copy all. Let's replace all of this with the one which we have copied. Basically, we are just changing, instead of localhost, we are providing the container name, and also we are changing the username and the password. That's it. Let's save this. And the next step is we need to build the Spring Boot Docker image. Before that, we need to build this expense tracker API. We need to build the jar. So let's go to Maven and choose install and click on this Maven build. This will take a few minutes to build the jar file. You can see build success. Inside the target folder, we have the expense tracker API.jar file. Next, we need to create a Docker file. So inside the root of the project, we are going to create a new file, Docker file. Let me minimize all of this, and let's start with from instruction from open JDK : we're going to use JDK 8. Next, we are going to use the copy instruction. We're going to copy the jar file which is present inside the target folder, expense tracker API.jar, and we're going to copy it to the image which is having the same jar file name, which is expense tracker API.jar, and we will use the entry point instruction, and we will provide the Java command which is java -jar, and we will provide the image name which is expense tracker API.jar. Let's save this. So now we have the Docker file. All we need to do is we need to build this image. Let's open the terminal, and we are going to use docker build command, docker build, and we need to provide the repository name. We are going to call this, let me see what I can return in the instructions, in the steps, Spring Boot MySQL. You can give any name you want, but I have just already written the document. I'm following that, and we need to build it inside the current directory. So let's put a dot and hit enter. This is going to build the Docker image. This will take a couple of minutes. Once the Docker image is built, we can verify that Docker images, and you can see we have the image Spring Boot MySQL. The tag is latest, and the size is 564 MB. Next, the last step is we need to start the Spring Boot container on the same network. So we're going to use the docker run command, and we will use the -- network to run it on the network which we have created earlier, Spring Boot -MySQL -net, and we will provide the name to the container using the -- name option. We're going to call this Spring Boot -container, and we're going to provide the port using the port option -p option, the host port and the container port, and we're going to run it in the detached mode, and we are going to provide the container name, which is Spring Boot MySQL. Not the container name, this is the repository name. Let's do this. Docker run, we're going to use the run command, and we are going to use a network. We need to run it in the same network, Spring Boot MySQL -net, and we need to use the -- name option to provide the container name. Let's call this Spring Boot container, Spring Boot container, and we're going to use the port -p option. We will provide the host port. Basically, I'm going to map the same port 8080, which is the host port, and the container port, which is 8080, and we're going to run it in the detached mode, and we need to provide the repository name, which is Spring Boot MySQL, and hit enter. This will start the container. We can verify that, docker ps. You can see it is started, and this will take a couple of seconds to run. We can check the logs, docker logs, the container ID, which is cca, hit enter. You can see it is started on the port 8080. We can check inside the database whether the tables are created or not. Let's open the command prompt or the terminal, and inside this let's use show tables. Hit enter. You can see we have the two tables has been created, tbl_expenses, tbl_users. Right now there are no records inside this. We can verify that. Select star from tbl_users. Hit enter. See, we have an empty set. Let's go to the postman. Let's fire a new request. This is a post request, localhost :8080/API/v1/register. First we need to register. Choose body, select raw, and choose JSON. Let's provide the name, which is Bhushan. Email bhushan@example.com. We need to provide the password 123456 and click on the send. We do get the response back, and let's change this to login. We don't need this name. Click send. We should get the JWT token back. Our application is working as expected. Let's verify it in the database. Hit enter. We do get a user which we have created just now, Bhushan. And if you want to exit from this MySQL interactive mode, you can write exit. You will come out of the MySQL. If you come out of this container as well, you just need to again use exit. You will come out of the container, and still our containers will be running. You can see there are two containers are running. If you want to stop the containers, you can use docker stop. You need to provide the container ID cca and also 457. Hit enter. Both have been stopped. Okay, this is 454. Hit enter. You can see the service is stopped, the container is stopped. We can verify it. Exited 18 seconds ago, exited 4 seconds ago. Alright, this is all about Dockerizing the Spring Boot application with the MySQL database. We have used one of the approach by creating the Docker network. There is also one more way we can use the Docker Compose that we will see in the next video. Thank you so much for watching. In case if you are enjoying this Docker series, go ahead and share this playlist with your friends, and also in case if you like the video, go ahead and smash that thumbs up button and also subscribe to the channel. I will see you in the next video. Hi, welcome back to my YouTube channel. In this video, we're going to Dockerize the Spring Boot application with MySQL database. In the previous video, we also Dockerized the Spring Boot application with MySQL database, but we have used the different approach. We have used it by creating the Docker network, and in this video, we're going to Dockerize it using the Docker Compose. In case if you missed the previous video, the link will be given in the description section of this video. Go ahead and watch that video. Now let's continue with this video. We are going to Dockerize the same application which we have Dockerized in the previous video, which is the expense tracker API. In case if you don't know how to create a RESTful API using Spring Boot and JPA, I highly recommend you to check out my Udemy premium course, where I will teach you everything you need to know about Spring Boot, JPA, Hibernate, and deploying the application to the Heroku and AWS. The link will be given in the description section of this video. Go ahead and check that course as well. Inside this expense tracker API, we have already created the Docker file. We have provided all the instructions to build this project and start the container. And we are going to create the Docker Compose file at the root of this project. Right click on this and create a file. We're going to provide a file name, which is docker-compose.yaml file. We're going to create a YAML file. The extension is YML. In case if you're not familiar with the YAML file syntax, I highly recommend you to get familiar with the YAML file syntax. This file starts with the version property. We need to provide the version for this Docker Compose file. That will varies from version to version. Depending upon the version you have installed, you have to provide this. So I have installed the Docker version, which is 20.10. So I'll open up one of the link which is provided, which is mentioned in the Docker official website. If you go inside this, you have to pick the version and you have to specify the compose file version. I have installed 20 point something, so I have installed the 20 point plus version. So I'm going to pick the latest one, which is 3.8. Depending upon the version you have installed, you have to pick the compose specification version. Let's go to the IntelliJ IDEA. Let's add the version property. I will set this to 3.8. Next, we are going to add the property services. We have to specify all the services which we are going to Dockerize it. We are going to Dockerize it two applications. One is a MySQL database as well as the Spring Boot application. So I'm going to provide a name for Spring Boot application, which is server. You can give any name you want. Inside this, we are going to add the property build. We need to specify where the application has to build, and inside the current directory, we are going to build it. Next, we are going to add the property restart. I'll set this to always. This says that whenever the container stopped, we are going to start it automatically. We are going to restart it automatically. That is what the restart always. And we need to specify the ports. We know that we have to specify two ports. One is the container port as well as the host port. Both I will set this to the same port just for the consistency. Next, we have to add the depends on property. We need to tell this Spring Boot application depends on any other services. Yes, it depends on the MySQL database, and we're going to provide the value for that, which is MySQL DB. You can give any name you want. Once the Docker reads this property, it is going to first start this container, the dependent container, and then once the dependent container is started, it is going to start the Spring Boot application. Next, we need to create a service with the same name, which is MySQL DB, and inside this we will add the platform. I will add Linux/x86_64. If you are using Windows, you don't have to set this. I'm using Mac M1, that is why I have added this property. If I don't add this property, I'll get an exception. Next, I will add the property image, we need to tell the MySQL image that we're going to pull from the Docker Hub. We're going to pull from the Docker Hub, which is MySQL colon 5.7, which is the tag name 5.7. And I will also set the restart to always for this MySQL DB service. And I will add the ports. We are going to add the 2 ports like I said, but I'm going to add it to a different port, 3307. This is the host port and the container port is 3306. Because I'm setting it to a different port because in my local system there is already a MySQL database is already running which uses the 3306 port. If I set it to the same port, then I'll get an exception that is already address is already in use or the port is already in use. That's why I have set it to a different port. Next, we need to add the environment variables. We will add MySQL database name, database colon expense tracker, MySQL user. We need to create a user, scbhushan05. You can give any name you want. Next, the password for the user, MySQL password, scbhushan05. I will give same value just for the consistency. Next, we need to set the root password, MySQL root password. I will set the root password with the same value. The username and the password and the root password, I'll set this to a same value just for the consistency. Now let's save this. Next, we need to build this. Before that, inside our application.properties file, we need to change the properties according to the environment variables. The database name, which is same, but instead of the localhost, we need to provide the service, which is MySQL DB, which is the container name, MySQL DB, and the username, which is the same as the password. So let's copy and paste it. Now let's save this. Next, we need to build this. So let's go to the Maven and click on this install, click on this Maven build. This is going to generate the jar file inside the target folder. Build is success. Let me minimize all of this. Let me open the terminal. Inside this, if you look at this Docker images, right now we do not have any images for the Spring Boot application as well as the MySQL. What I'll do is I'm going to use docker -compose, and we need to use the up option, hit enter. This is going to first pull the MySQL image, because if you look at this our server depends on the MySQL DB. So it is going to pull the MySQL 5.7 from the Docker Hub. This will take a couple of minutes. I'm going to pause the video and I'll come back once it is downloaded.
A few moments later.
Okay, it is almost done. Let's wait for a couple of seconds. As you can see, our Tomcat is started on the port 8080. First, let's verify whether the database is created or not. What I'll do is I'm going to open the MySQL workbench. Let me open the MySQL workbench. I'm going to create a new connection. Click on this plus icon, provide the connection name. I'm going to call this Docker DB, and change the port to 3307. That is what we have mapped our container port to the host port. The username scbhushan05, the password, which is also same. So I'll copy this and add the password and click OK, and click on this test connection to test the connection. Successfully made the MySQL connection. Click OK, and click on this new connection, and you can see we have the expense tracker database has been created. Double click on this. Inside the tables we have two tables, tbl_users, tbl_expenses. Now let's go to the terminal and let's see how many images it has been created. We have two images created. One is expense tracker API underscore server and the MySQL server, MySQL container. Let's use the Docker PS. The two containers are running. One is the Spring Boot application, another one is the MySQL server. Now let's go to the Postman. Let's test our APIs. Localhost :8080/API/v1/register. Choose body, raw, and make it JSON. We will provide the request body. Email bhushan@example.com. Name, I'll set this to Bhushan. Password, I'll set this to 123456. Click on this send. We do get the response back. We can verify with the database entries. Click on this TBL users. You can see a new record has been created with the name Bhushan. Awesome. So this is the another approach that we can make Dockerize our application using Spring Boot and MySQL database with the help of the Docker Compose. I hope you have learned something out of this video. In case if you have any questions, leave your questions in the comment section. That's it for this video. Thank you so much for watching. If you like this video, go ahead and smash that like button and subscribe to the channel for future videos. I will see you in the next video.